Good afternoon, students. The topic that we'll discuss today is peptide mass fingerprinting. By this technique, basically, protein identification is done. As I said earlier, peptide mass fingerprinting is a high throughput technique which is used for identification of proteins. Now, how the proteins are identified? The protein of interest is splitted into smaller peptides, and then the mass of these peptides is measured by the technique of mass spectrometry using mass spectrometer such as MALDI TOF or ESI TOF. MALDI stands for Matrix Assisted Laser Desorption Ionization and TOF is for time of flight, whereas ESI TOF is electrospray ionization time of flight. This method was first of all developed in 1993. As we can see in this slide, peptide means protein fragment which is often generated by trypsin. Mass means the molecular size of peptides, and the fingerprinting presents the uniqueness of the masses of the peptides. This technique means that the digestion of a protein by an enzyme can provide a specific fingerprint of great specificity which can possibly identify the protein from this information alone. With this slide, I'll try to explain the basic procedure of peptide mass fingerprinting. The standard approach to identify the proteins includes separation of proteins by gel electrophoresis or liquid chromatography as shown in the slide. Subsequently, the proteins are cleaved with sequence-specific endoproteases, mostly trypsin. Following digestion, the generated peptides are investigated by the determination of molecular masses or generation of peptide fragments. For protein identification, the experimentally obtained masses are then compared with the theoretical peptide masses of proteins stored in databases by means of the mass search programs available. First step is sample preparation. For this, we have already seen that two-dimensional gel electrophoresis is the preferred method for protein separation prior to peptide mass fingerprinting. Thereafter, the protein is cleaved into several fragments using proteolytic enzymes. In this case, trypsin is the most favored enzyme. Why? Because trypsin is relatively cheap, highly effective, and generates peptides with an average size of about 8 to 10 amino acids, which is ideally suited for analysis by mass spectrometry. Now, the steps for MALDI-TOF analysis. MALDI is considered to be a soft ionization technique that involves a laser striking a matrix of small molecules to make the analyte molecules into the gas phase without fragmenting. Therefore, MALDI is appropriate to analyze biomolecules like peptides. As we can see in this slide, the MALDI methodology is a three-step process. First, the sample is mixed with a suitable matrix material and applied to a metal plate. Second, a pulsed laser irradiates the sample, triggering ablation and desorption of the sample and matrix material. Finally, the analyte molecules are ionized by being protonated or deprotonated in the hot plumule of ablated gases, and then they can be accelerated into whichever mass spectrometer is used to analyze them. In this case, it is a time of flight mass spectrometer, mainly due to its large mass range. The TOF measurement procedure is also ideally suited to the MALDI ionization process because the pulsed laser takes individual shots rather than working in continuous operation. The mass spectrometric analysis now produces a peak list, which is a list of molecular weights of the fragments. In silico digestion. In this, software performs in silico digestion on database proteins with the same enzyme used in the experimental digestion and generates a theoretical peak list. Mascot, MSFit, and Profound are the most frequently used search programs for peptide mass fingerprinting. Now, moving on to the advantages of this technique. The first advantage is that proteins can be identified from peptide signature. Second, it does not require too much of sample optimization and can be done by a moderately skilled operator. This slide highlights the disadvantages. One of the major disadvantages is that the mixture protein can complicate the analysis and also potentially compromise the results. Secondly, the post-translational modifications cannot be easily identified. This slide will provide us an overview of the peptide mass fingerprinting technique which we have discussed so far. The steps include: first step is protein separation, followed by its digestion. Third is analysis using mass spectrometry, followed by in silico digestion, and finally comparison. I will end my presentation with this reference paper which can be further consulted. Thank you all. Stay home, stay safe.